We continue learning workbook page 119 with some problems. Divide. Write the quotient in a plus bi form. All right, this is going to feel very similar to the skill we learned at the end of section 7.5 when we were working on rationalizing denominators that contain two terms using a conjugate. All right, the first thing you want to do is copy your problem. So make another fraction, an identical fraction. Then you want to identify what is the conjugate of the denominator. The conjugate of the denominator is 5 minus 2i, so the conjugate of the denominator would be 5 plus 2i. So we're going to multiply top and bottom of our fraction by 5 plus 2i. Okay, now combine your two fractions together. So we get 8 minus I times 5 plus 2i divided by 5 minus 2i times 5 plus 2i. Next, FOIL. So we get 8 times 5, which is 40. 8 times positive 2i, is plus 16i. Negative I times 5 makes subtract 5i. And negative I times 2i makes subtract 2i squared. Over 5 times 5, 25. 5 times positive 2i makes plus 10i. Negative 2i times 5 makes subtract 10i. Negative 2i times positive 2i makes subtract 4i squared. Combine your like terms. 40 plus 11i minus 2i squared. But we know that I squared is the same as the number negative 1, so we're going to replace I squared with negative 1. And in the bottom we have 25. These cancel, plus 10i minus 10i, minus 4i squared. But again, I squared is the number negative 1, so we'll write 4 times negative 1. All right, so then we have 40 plus 11i plus 2 over 25 plus 4. Notice we're subtracting a negative, so that's why it turns into adding. 42 plus 11i over 29. Now this is equivalent to the final answer, but we have to write our final answer in a plus bi form, which means I is not allowed to be part of a fraction. So we draw the heart, and each one of the pieces of our numerator gets divided by the denominator. So then we have 42 over 29 plus 11i over 29. And then finally, we move the I to the right because I is not allowed to be inside a fraction. And we get our final answer, 42 29ths plus 11 29ths I. If it was possible to simplify either one of these fractions, we would be required to do so. But 29 is a prime number, and therefore neither of these fractions can be reduced. Okay, let's do one more problem of this same type. Before we do this problem, I would like to remind you about complex conjugates. The complex conjugate is found by changing the sign of the imaginary part of the complex number. So for example, if you start with I, then the complex conjugate would be negative I. All right, let's solve a problem involving that skill. Divide. Write the quotient in a plus bi form. We've got 2 divided by I. Okay, the first step is to create an exact copy of that fraction. The second step is to identify the conjugate of the denominator. The conjugate of I is negative I. So multiply top and bottom by the conjugate. Now multiply the fractions. 2 times negative I would be negative 2I. I times negative I would be negative I squared. Now this is where you want to be very careful. I squared is the number negative 1. So negative I squared would be the number positive 1. And anything divided by 1 is itself, so we get negative 2I. Now, you might notice that this does not appear to match the form required for this problem. You might be thinking to yourself, don't I have to have a number in front? The number in front technically is there, it's just hidden, it's 0. You could write this as 0 subtract 2I. But simplifying involving 0 would take us right back to where we are, so this is our final answer for this particular problem.